Hello, hello, and welcome. Mindset is great, and Mindset is it is a lovely Tuesday time for physical sciences with me, Abram, and joining the studio. If you're joining us now, welcome. I know that you're going to enjoy this show. You've been waiting for it. Here it is, just for you. John, how are you?
Very good, AB. Welcome, guys. I hope you're ready for this. I know that some of you find this section and you've been told that it's difficult. But guys, it's not. It's like laying eggs. It's like counting eggs. It's like counting sweets. It's really quite fun, and it's really quite easy. If you get this in grade 10, you can ace chemistry for the rest of grade 11 and 12. And guess what? These questions that we're doing today could even appear in the grade 12 exam. Okay? So you need to focus. You need to get your act together, get your pens out, copy down, ask questions. AB will tell you where to get the notes.
And so I hear it's easy as laying eggs. I wonder if you have some experience, John.
No.
I'll save that for later. It should be easy then. Well, Mindset, there are a lot of things happening, but it's exciting. We've got exciting competitions just for you guys. Remember, first of all, we have your notes on facebook.com/learnextra. They're already posted. There's the viewing option, the download option, and the test yourself.
Hey, but hold on. Wait a minute. AB, you're rushing. Guys, get onto Facebook. There's a whole new picture on Facebook, isn't there?
Yes.
Let's find out. Let's get into this. First,
all right. First things first, new stuff.
New stuff. Tell us about it. What's going on?
Well, there's a new hashtag now, Get Connected. So we're connecting with you guys and with us. So Mindset is connecting with you guys, but we've got prizes that are probably sponsored by Vodacom. All you need to do is to jump on our Facebook page and check out what the competition is all about. First of all, the steps that you're going to get is you need to click on the link that will take you to Curio.
Okay, wait a minute. Let's just slow down. He's like a train this afternoon. I don't know why. So all the information's in the top and we're going to keep it posted there on the top of the page. And the first thing you're going to do is you're going to go to the link for Curio. Curio you can access on a mobile phone, and you can access it on a computer, you can access it on a tablet. It's just that http://q.na/ if you want. You're going to ask to register, put your name in, give us some details. Then the next thing is you're going to ask for a code. The code is Learn. You can spell it with capital letters, with lowercase letters, with a capital or a lowercase. It will still all work. So Learn is the code. Put Learn in. Then it'll take you to some questions, and it'll show you a graphic of some teachers. They're just 6 or so teachers, and they're further down the page, all on a... There we go. There's one of them. But I just want to get the one that's got all 6 together. Okay, let me see. There we go. Yep. Is there one on the left? There we go. We've got all the 6 teachers in, but they're in one graphic on the Curio page. Go and have a look at it. Numbered 1 to 6. You need to decide who's your favorite teacher out of these 6. Guys, there are other teachers coming up. We're going to be running this for the next 6 weeks or so.
Yes.
Hey? Right. So for 2 weeks, you've got 6 to choose from. We'll take 2 of those teachers, the best 2, put them into the final. The next week, 6 teachers again, another 2 go into the final. Next 2, then we've got 6 again. We'll do that final in the 4th term. Okay.
Very exciting, John.
So it's exciting, hey?
Let me get on the prizes.
Okay. What are the prizes for the most liked teacher?
All right. We've got 4 Sony Xperia L.
Hey, those are cool phones, eh?
Those are cool phones. So stylish. If you go up on the page, John, you can just actually show them.
Let's go to the...
There's
right
4
at
of
the
them
top.
up for grabs.
Yeah.
Those cool ones. And we've got about 60 airtime vouchers, 55 Rand airtime. Guys, we love giving airtime, and Vodacom is always generous. So you need to get connected with all your friends and us, of course, calling us. So we've got airtime that is also up for grab. All you need to do is to like the picture. As John has told you, the picture with the most likes, whoever has voted for that will go into the draw if the teacher has the most likes, and then you could win those awesome prizes.
Okay, let's just get the airtime straight. Guys, there's something here that we'd like you to do. For the airtime, it's not just about liking. We want you to share. So go to this post here that's at the top of the page, and share this graphic. Share this information with your friends. Share it as many times as you like. All the people that share it are going into this week's draw for airtime. Okay. So we've got quite a bit of airtime to give away. Everyone that shares has a chance of winning some airtime. Let's get the message out there. We want more people to share. We want more people to like. We want more people to learn more and learn extra.
That's so true, John. So guys, get connected right now. More information on facebook.com/learnextra. And now another competition is the awesome Casio calculator, which you all know by now. If you don't, get the test yourself questions, test yourself, and stand a chance of winning this awesome Casio calculator. John?
Okay, guys, enough of the commercial chat, but let's get on to this question of the mole and atomic mass. That's what we're going to be looking at today. We're going to be introducing the concept of the mole. So we're just going to introduce it. And as I said to you, it's a very important thing. We're going to discuss the importance of Avogadro's number and molar mass. We're going to look at how this applies to a balanced equation. We're going to solve some problems with moles, number, and mass. Now, here's your challenge question. We're going to get this posted in the ad break. I forgot to post it at the beginning, so I'll get it posted during the ad break. Make sure that you try it. Give us your answer, as many as you can. It's not an easy question, but I think you're all able to do it. So let's give it a try. Think about it. Let's get into the summary part of it. Now, Abram, here is the problem. The problem is atomic mass. If we've got something very small, okay, it's so small, how are we going to find its mass? Any ideas?
If it's so small in terms of its weight?
Yeah, its mass. It's tiny, tiny. Even the machine that it's made up of has to be so sensitive. How are we going to find the mass of one atom? Guys, do you have any ideas?
Let me think about it.
You're going to think about it. Well, let Abram think about it. Guys, if we can't find the mass of one atom, okay, then let's try, and if you think about this, even for practical purposes, if you are asked to find the mass of a small thing, let's say we're looking at something very small in that you'd find around your household. Say your mother's doing some sewing and she wants to pin pins onto the tracing paper to do the dress design. Okay, those little pins, how much do they, what's the mass of them? Well, if we have a kitchen scale and we're trying to find the mass of something as small as a pin, it's not going to be very accurate.
Nope.
1 on the scale makes hardly any difference. But if we took 100 or 1,000 or even 10,000 or 100,000, put them all together, put those on the scale, do you think it would make a difference?
I think it will.
Yeah, okay. So that's the first principle that I want you to understand. We can't measure the mass of an atom that is very small directly because it's too small to measure. It will not make a difference. We can't make a scale sensitive enough to measure it. So we've got to use a very big number of atoms. Now, Abram, remember I referred to eggs and counting eggs or laying eggs, watching a chicken lay eggs. Okay? Now, when you go to the shop, do you say to the spaza shop owner, I'd like 12 eggs? What do you say?
A dozen.
You say a dozen. So what does a dozen mean?
It means
12.
12 eggs.
Yeah. You don't go and say, I want 7 eggs. No, you say, I want half a dozen eggs. You buy eggs in either half dozen, 1 dozen. Maybe you're going to buy from the bakery. You buy 2 dozen rolls. How many rolls are you going to get? 2 times 12, which is 24. Agree? So guys, there's this word that we mean by the number 12, which is a special number. I don't know if you know, but in some of those spaza shops, you can get the bigger ones. You can get sweets in packets. The spaza shop owners actually go to these warehouses, and they buy those sweets that are cheap sweets, okay? And you get them in a big packet, and it says 144.
Yes.
And there's a special name for 12 dozen. We don't just say it's 144 or 12 dozen. Do you know what the name is?
No.
Okay, so here's a question that I want you to post on Facebook.
Okay.
What's a name for 144? Okay, go and look at it. Some of those little sweets that you buy 3 for 10 cents, or 4 for 10 cents, or 5 for 10 cents, depending how generous the spaza shop owner is. 144, there's a special name. Do you know what the name for that number 144 is? Okay, let me know as soon as they tell me what is 144.
Okay.
Now, guys, in chemistry, we've decided there are two things. We want to get a very big number of atoms because atoms are very small. And the second thing is we want to be able to compare atoms with other atoms. And so they say to us, do you want to compare? And when they originally did this, do we want to compare mass for mass? And so they decided, well, let's rather introduce a scale, a relative scale. Now, let me explain to you what a relative scale is. You can see that Abram is still very young and he hasn't eaten so much food, but I'm going to stand this way and you can see that I'm a little bit more rounded. Okay, now if Peter was on the show, then he would be even more rounded. But Abram is needing some feeding, okay? So if we wanted to compare myself and Abram in terms of mass, then we would have to have a standard, a unit standard. Just pretend we don't have scales, we don't have kilograms or grams, and we're going to say, because Abram is so healthy and young, we're going to call him the standard. Okay? If somebody is less than Abram, then he's below the standard. And if somebody is more like myself, is more than Abram, I might be worth 2 Abrams. Okay? Because he's little and I'm a little bit larger. Okay, so I want you to understand that this is a discussion that chemists had when they were dealing with trying to work out how to find the mass of atoms. They call it a relative scale. So in trying to decide what is the ideal number of atoms to weigh, to use as our standard, because we want to weigh a certain number of them and then take the same number of atoms of another element and compare them. And then you can say, what's the ratio between those two? So they tried different things. Some people suggested hydrogen, some people suggested oxygen, and other people suggested carbon. Now, eventually, the science community agreed, the chemists agreed, IUPAC agreed. IUPAC is the International Union of Pure and Applied Chemists, and you're going to be hearing a lot about IUPAC, particularly in grade 12. They set the rules for chemistry. And IUPAC decided that 12 grams of carbon isotope number 12. Let me just write this on the board for you. They decided that this was the important thing. If we could get carbon, now carbon is very common. It's very stable, and there is an isotope that's called carbon-12. What does that mean? It has the number of protons is equal to 6, so number of protons is 6, number of neutrons is also 6, and the number of electrons is also 6, but we're not worried about that because the electrons are so small in their mass. So we take carbon-12, and they say, well, we've got carbon-12, let's take 12 grams of it. And we're going to say this mass is our standard. This contains a special number of atoms. And that special number, we're going to give a name to. That special number, or that idea of 12 grams of carbon, has a special number, and we're going to call it something. We're going to call it give it a name. Just like we'd say A dozen is 12. 12 grams of carbon is called 1 mole. And there is a special number. So I hope you can see something here. We've got a mass. We've got a number. And we've got a name. Let me change the color there so it makes it more colorful. This is the name. And we, in this section, really want to link those two together. 3 things together. The number, the mass, and the name. Has anybody given me the number, this name for 144?
Yes, they say it's a dozen dozens.
No. It is 12 dozen, that's right. But there's one word for it. Guys, I think it's time for an ad break. Go and think about what 144 is. Is there any other answer?
Another answer, it's a gross.
Gross. That's it. You got it before the ad break.
Nice
so
one.
1 gross is 144. Now, the next question, follow-up question during the ad break. Please tell me, what's the special number? That is 12 grams of carbon. That's 1 mole. What's the special number? Let's think about that, and we'll talk about it after the break.
Right, cool. You also have the challenge question, guys, during this ad break. Check it out on Facebook.
It's not up yet.
Oh, it's not up yet.
I'm going to put it up in the break.
All right, so you have to do this question. We'll see you after this break. Welcome back, awesome mindsetters. If you just joined now, you're a bit late because John has covered some important stuff that I think when you are about to do this lesson, you really need to know them. But otherwise, the notes are up on the page, so check them out. Or else you can just go to learn.mindset.co.za. That's where you'll also get the schedule, also view previous notes in case you missed them, and also get the links to the videos on that link. Once more, it is learn.mindset.co.za. Otherwise, follow us on Twitter at LearnExtra. I'll be reading some of your tweets and see what are you guys saying on Twitter, and also right here on Facebook, which is facebook.com/LearnExtra. Looking at the competition that we have, which is probably sponsored by Vodacom, it is Get Connected with Vodacom and Mindset. There's about 15 shares. Wow, you guys really want these airtimes. Remember, we've got 60 55 Rand Vodacom airtime. So guys, make sure that you get sharing as many times as you can, because the first draw will be next week on Monday. So you better check out your name in there. John?
Thanks so much, AB. Guys, if you don't get involved, if you don't get connected, you're going to miss out. So get connected. Because in getting connected, you're getting connected to the notes, you're getting connected to the help desk, you're getting connected to the TV, you're getting connected to the teachers. There are a whole lot of fun things that we're going to be doing. We want to get you connected, because if you get connected, you're going to succeed. Now, what about that connection about the number in the moles? Have we got that yet?
Yes, we do.
Okay, let's see what it is.
Okay, they say it's 6,022 times 10 to the power 23.
Excellent, well done.
And someone named it, it's a Avogadro number.
Avogadro's number, excellent, guys. So check out the notes, it's got it all there. There's just one last thing that I want to mention, in fact, we can just mention it as we're doing the questions. It's very important when we're doing chemistry to remember that simple relationship. The name, a mole, number of moles. The number starts with an N, name with an N as well. So remember that. Name is the number of moles, little n. The number, capital N. And mass, we'll use M's for the mass. We'll see how it works. So let's go to the first question and let's just check out how we're doing. I'm sure you're going to manage this really well. If you remember those principles, you've got it sorted. Okay, so here we go. It tells us a helium balloon contains 4,3 mole of helium gas. Now, guys, just stop there for a minute. Very, very important. When you're told that you're given a gas, you must think for yourself, what's the chemical formula? And I suggest you write it down. In this case, we know that helium is in group 18. It's a noble gas. So I can write it down as He. it's not going to combine with anything. But if it was hydrogen gas or oxygen gas, then I've got to write it as the diatomic H2 or O2. Diatomic, 2 atoms for every molecule. But helium, only 1 atom. It's monatomic. Okay, so that's the first point to remember. Next thing, we were told that the number of moles is 4,3. So I'm going to write down 4,3 mole, and I'm using the little n as the symbol for number of moles. Now, what's the question asked? It says, how many atoms are there in 4,3 moles of helium? Guys, there are 2 formulas that you need to know here. The first one is the one we're going to use, that the number of moles is equal to the number of things that we want divided by Avogadro's number. And so it's really quite simple. You just got to remember those 3 things. The number of moles, the number that we want or have is equal to Avogadro's number. So that's what it looks like on the data sheet, on the formula sheet. And what I suggest is that you substitute directly into that formula. Now, seeing I haven't got a lot of space, I'm going to write it over here. 4,3 is equal to n, I don't know the number, I'm going to try and find that, divided by Avogadro's number, which is 6,022 times 10 to the 23. Now, in the old days, that used to give us a whole lot of problems, but now with the Casio calculator, it's really quite easy. So I want to show you how you put that together. Of course, once you've substituted, you don't just want to leave it like that. You want to get the number of atoms into the right position. So I'm going to remind myself, whenever I'm asking, using this formula, I want the number of atoms of helium. And I'm going to put that next to it, almost in brackets. So I can remember that I'm looking for atoms. To get the subject of the formula right, I'm going to change it to atoms of helium is equal to, multiply both sides, so we got 4,3 multiplied by 6,022 times 10 to the 23. And let's see what our calculator gives us as an answer. So we're going to go 4,3 times, now look, 6,022. Don't write times. Just say times 10 to the 23. The times 10 to the power of x, the button at the bottom there that I highlighted. And we're going to put the power up as 23. Fill it in. Don't put a negative or anything with it. And we get the answer as 2,589. So I'm going to round that off to 2,59 times 10 to the 24. So 2,59 times 10 to the 24. Atoms of helium. Please, whenever you're using this equation, you must specify in your answer what things you're looking for. Because you could get asked, how many electrons have I got in this amount? How many protons have I got? How many ions have I got? How many molecules have I got? All of those are possible questions that you need to. So be specific. And in this case, we knew that we had a noble gas, so we only had atoms. And that's why we could answer it like that. Okay, next idea carries on to say, so what is the mass of this sample? What's the mass of the sample of helium? So what have we got? We've got our second sort of equation that we're going to deal with. We've got mass. Sorry, let's just do it again. It always starts with number of moles is equal to the mass divided by the molar mass. The mass of 1 mole. Now the mass of 1 mole is known as the molar mass. It's given on the periodic table. So if we look on the periodic table, there's the atomic number and there's the relative atomic number. The relative atomic number doesn't just look at one isotope. Remember, the standard for the number of atoms was carbon-12 isotope. But the relative atomic number takes the average sample of isotopes. So looks at the percentage of isotopes that are in a normal sample. It then gives an average mass for those, and it's based on the carbon-12. Carbon-12 has so many atoms, so every other thing with that molar mass, the number given on the relative atomic mass on the periodic table, that will be for the individual elements. When we put elements together and we make compounds and we make molecules like oxygen with O2, then we've got to take into account the relative atomic mass from the periodic table multiplied by 2 to give us the molar mass. But in this case, we're dealing with helium. So we just need the number from helium. Now, in terms of that, I didn't remember to put up the periodic table, but fortunately I remember that helium has it's the second element, atomic number of 2, and it has a molar mass of 4, so we're going to, or a relative atomic mass of 4, so we're going to use 4. Sometimes they give it to you in more than one decimal place. We're just going to use it as 4 for the moment. So what have we got? What have we been given, and what can we find? Well, we're given the number of moles, so I'm going to, seeing I've got space, I'm going to spread out a little bit. 4, 3 is equal to, the mass is unknown, but the molar mass is 4. So I think you can see that if you multiply both sides by 4, you're going to get the mass is equal to 4, 3 times, well, that was a terrible 3, so let me just do it again. 4, 3 times 4, and I'm not going to trust my head to do that. I'm going to use the calculator, and we're going to say 4 times 4, 3, which gives us an answer of 17,2, which sounds about right, 17,2. Okay? We know that 4 fours are 16, so we estimate it should be a little bit more than 16, and that's what we've got. We've got a little bit more than 16. Guys, I hope you've got that. Hope you're beginning to see that magical relationship, and I just want to illustrate it again so that you can get it clear that we've got this relationship between the name, which is the number of moles, and over here we've got mass, and here we've got number. Okay, and those all link to each other. How does number of moles and mass link to each other? N is equal to mass over molar mass. Where am I going to find the molar mass? I'm going to look on the periodic table. Must have that periodic table in front of you, so you can look at that. What about mass and number? Well, you're going to need to do that in 2 steps. What about number and the name, the number of moles, and the number of things, whether it be atoms or etc., particles or whatever? The number of things is the number over Avogadro's number, where Na is equal to 6,022 times 10 to the 23. Okay, guys, I'm sure you're starting to see that this relationship is not that difficult to deal with. But let's go on to the next question. Question number 2, we want to move on this one a little quickly because I definitely want to get to the third question, and if we haven't got time, we'll do that in the third segment as well. So a sample of dry ice consists of 1,2 times 10 to the 24 molecules of carbon dioxide. Now guys, they told us it's molecules, it's not atoms, it's molecules. We need to think clearly. How many moles of carbon dioxide molecules are present? So how many moles of carbon dioxide? Very nice question, because they're asking about molecules and they're giving you molecules. So we're going to say the number of moles of CO2 molecules is equal to the number present divided by Avogadro's number. And so the number is 1,2 times 10 to the 24 divided by 6,022 times 10 to the 23. And if we do that on our calculator, let's pull the calculator to this side, and we'll get it. We're going to say 1,2 exponent 24 divided by 6,022 exponent 23. And we say it's equal to 1,992 moles. So I'm going to write down it as 1,99 to correct to 2 decimal places. 1,99. And that's the number of carbon dioxide moles. Molecules of carbon dioxide. Please also notice something. The unit is MOL. Don't write MOLES. It's mole. Okay? That's the SI unit. We must be very strict about that. Because in the exams, you might find that there's a problem if you're not. So then they ask us, well, what's the mass of the sample? How do we get from number to mass? Moles to mass? Well, that's not difficult. The mass, remember, the number of moles is equal to the mass divided by the molar mass. Now, the molar mass, I'm going to just do some working on the side here. The molar mass of carbon dioxide is equal to 12 from carbon plus 16 from oxygen, but there must be times 2. And this, when you add it together, 32 plus 12 is 44 grams per mole. Okay, so I now know the molar mass. I've worked it out from the periodic table. What about the thing that I'm trying to find is what's the mass? So I'm not going to change the subject of the formula. I'm going to put my answer in. 1,99 is equal to the mass divided by 44. Can now multiply through by 44, and I get 1,99, put it in brackets, multiplied by 44, and let's see, it's going to be close to 88. Just multiply, round off, don't use the thing that's on the calculator. If you round it off an answer, put it in times 44, and we get the answer of 87,56. So 87,56 grams of dry ice or steam ice. You've seen steam ice, eh? Dry ice. That's the thing that you find in the ice cream container. And this one has a mass of, a nice block of it, 87,56 grams. Now, the next thing is, and here I want you to be very careful. Let's unpack this. How many oxygen atoms are present in the sample? Guys, wow. This is a challenge. Not too much of a challenge for you, I hope, but let's have a look at it. We recognize we've got in 1 mole, let me just erase that, in 1 mole of carbon dioxide, of CO2. For every one of these things, let's just draw it over here. There's the carbon, there's the oxygen, and we've got 2. So, and I perhaps should have drawn them a little bit bigger. So I'm going to make the pink ones oxygen and the orange one carbon. So if that's the case like that, carbon dioxide, it should even be a little straighter than that. What we recognize for every one of these things, we've got 2 of the shaded things, 2 oxygens. So however many moles of carbon dioxide I've got, I must multiply the number of moles of CO2 is multiplied by 2 is equal to the number of moles of O atoms. Because it's a ratio. It's a simple ratio. In every 1 molecule, there are 2 oxygen atoms. So if I know that there was 1,9 moles of carbon dioxide, I therefore know that the number of moles of atoms is 1,99 times 2. Take the calculator. 2 times 2 is 4. It should be close to 4. Let's just do it accurately. 1,99 times 2 equals 3,98. 3,98. Okay. The last part of this question is, what's the mass of carbon present? Well, we know that the number of moles is 1,99 in the carbon dioxide molecules. But look here. The number of carbon in one of those, the ratio is 1 to 1. For every molecule, there's one of those, so the number of moles of carbon is that. And so what's the mass of that? Well, we know the mass is going to be equal to the number of moles divided by, a number of moles is equal to mass divided by molar mass. And if we do the substitution, we're going to get 1,99. The mass of carbon, we're going to round it off to be 12. Okay? And so therefore we can say the mass of carbon is 1,99 times 12. And let's quickly do it on the calculator. 1,99 times 12. And we get the answer of 23,88. 23,88 grams. So out of the whole 67 grams, where did we have it? No, 87 grams. 23,88 of those grams is oxygen, and the balance is the balance is oxygen. This was carbon. 23,88 is carbon. The balance is oxygen. And we're not surprised, because we'd expect there to be more oxygen than carbon. AB?
Thank you so much. That's a bit too much to take on. The Mansiters really need a break.
I think they do need a little bit of a break, but guys, don't go away. The challenge question is waiting for you.
Of course, there's so much to do during this break. Remember, you can still post some of the questions. If you're struggling anywhere, I've seen some questions, and we'll take them later on, so stay tuned. Welcome back, Grade 10s. Now, still in the giving mood, we've got another exciting competition, which is called the Water Game, a serious competition that is based on water, teaching you guys, or trying to create an awareness on the use of water. So all you need to do is to log on to www.watergame.co.za, and also more information will be on our Facebook page, but always check out the hashtag, which is #SAWaterGame, where you stand a chance of winning some cool prizes. There's cash prize money ranging from 5,000 Rand to 2,000 Rand. So guys, do check that out. There's a bursary also worth 15,000 Rand, but there are terms and conditions that do apply. So check out more information on facebook.com/learnextra.
Okay, AB. Now, we're going to be, thank you for that, and for the water game. Guys, we've been talking about water, and we've been talking about chemical reactions in water. But I thought, well, let's just throw in one of those solution type problems to calculating some moles in the challenge question. And so we know that if we were to test for chlorides, what we would do is we'd add some silver nitrate. Give us a precipitate. If it's a white precipitate that remains in acid, we know that we've got chlorides. Now, there are ways of determining how much a chlorine or chlorides you have present in a solution that don't use this method. This isn't as accurate, but I thought, well, let's just throw in a question that's related to water as well. Make sure that you understand that every time we dissolve something into water, we're creating pollution, and we need to control that. We're fast running out of water, particularly in our country where it's very dry, and all sorts of natural disasters can happen. By the way, did you hear the earth shake today, or did you feel it shaking? I mean, that's an amazing thing. I've been around for quite a while, and I've never felt an earth tremor like that.
Were you scared?
No, I wasn't too scared.
Okay.
It was only afterwards, and it carried on, and I thought, no, there must be something strange happening here. But no, it didn't get to that, so it wasn't as bad as I believe in some places. It was really quite bad, and was quite frightening. So perhaps you'd like to tell us about your earth-moving experience today. That you could post on the page as well. So let's have a look at the challenge question. And the thing I like about this question, and the reason I've done it, is because it's got a chemical equation in it as well. And what we need to recognize is with every chemical equation that is balanced, it tells us the number of moles that are reacting and the number of moles that are produced. It gives us a ratio of them. So in this one, we can see that there's no balancing coefficient in front. There's a missing number there. We take that number to be 1. And so we can say 1 mole of potassium chloride reacts with 1 mole of silver nitrate to produce 1 mole of silver chloride and 1 mole of potassium nitrate. So as long as we understand every balanced equation gives us a ratio of moles. We'll be doing some more of these calculations in a future lesson. But for the moment, please make sure you understand that. It's just adding one extra dimension to our little our formula, our 2 formula. Now we've got a ratio formula, and we've used that there. So now what do they tell us? They tell us that the mass of the precipitate. So what's the precipitate? Well, that's easy. It's the potassium. It's the silver nitrate, silver chloride at least. I got it wrong the first 2 times, but we've got it there marked as silver chloride. It's the thing that's the solid. Precipitate falls to the bottom. And we're told that the mass of this solid is 1,44 grams. We said if there were 6,02 times 10 to the 22 chloride ions in the solution at the start, how many moles of potassium chloride remain in the solution after the precipitation has formed, after the precipitate has formed? Okay, so guys, we now have a real challenge, because what we've got to do is we've got to work out and recognize that there is a combination here. Let's work out the mass. We've got the mass of silver chloride. We've got the mass of silver chloride that was formed. But what we've got to do is we've got to work out the number of moles. The number of moles is going to be the mass over the molar mass. Agree? Now, make sure that you understand this. That if we've got 144 grams, if we can work out the number of moles, then we can take that number of moles away from the ones that were there originally. If we take those away, we'll be left with what's left over that's still in solution. AB, I didn't get my periodic table up in the break. I was too busy looking at the Facebook page. So please won't you Google for me the molar mass of silver, or the relative atomic mass of silver, even if you just put silver on the periodic table and tell me the number. I think it's about 80 something, but we'll get it now. So what we need to do is we first of all need to work out the molar mass of silver chloride. Now, AB's busy looking it up, and perhaps if you know it, you can see it, you can work it out as well. I'm going to say 80 something plus chlorine, and I remember what chlorine is, 35,5 or 35,45. I'll use 35,5. Have you got it?
Okay, I'm checking now.
Okay, give us a second or two, and that's fine. The second thing that I'm going to do is I'm going to also, at this point, work out how many moles of chloride ions I had. So I'm going to leave that one for the moment, and I'm going to say, what's the number of chloride ions that I had to start with? So the number of chloride ions, the number of moles of chloride ions was 6,02 times 10 to the 22. 6,02 times 10 to the 22 divided by 6,022 times 10 to the 23. Now, if we do that on the calculator, let's just do it. We go 6,02 exponent 22 divided by 6,022 exponent 23, and we'll get an answer of 0,099996. I'm going to round that off to 2 decimal places, and I'm going to say that was 0,01 mole. That's how many moles of chloride ions. Remember what I said to you? You must say what you've got. So mole of chloride ions that were present. Now, remember what we said. For every one chloride ion in this reaction, there's the chloride ion, it's going to go 1 to 1. So whatever was there whatever is here came from there. So what we need to recognize now is what's that second calculation. Let's pick it up. Silver, 80.
I get 86.
86, just 86.
I hope it's correct. It's
It's
107.86820. 107.
No, it's not 107. It's definitely not 107. Okay, well, let's take it at 86. I think it was 143 when I did it earlier, and I just can't remember exactly. Let's take about 86. Let's see if we've got it. 86 plus 35,5, and that gives us 121. I think it might be a bit down. But let's just say that this is the molar mass of silver chloride. 121, what was that? 121,5. So if we've got the molar mass of that, what we're going to do is we're going to say the mass was 1. That's it. Guys, I'm going to just change this. There's a number wrong here. I know that number is not right, but I remember now that I made the solution look like this. I know that it comes out to about 144. I'm going to call it 144 because that was what I wanted to work with. So I'm going to say 1,44 divided by 144. If it was 143,5, you'll have to forgive me. But it's not 121. Just check it out on a periodic table. The big number under the silver sign divided by 144 equals 100th. So if we get that as an answer in decimal, 0,1. 0,01. So guys, what it's looking to me like, that's 0,01, and the number of moles of chlorine that we had originally was 0,01 mole. So what can we say? Is there anything left? No, because there's 0,01, 0,01. If there was, you would subtract them, but in this case, the answer is all the chloride ions have precipitated. AB, there were some questions on the page.
Right, there's this one question it's from Blay, saying, why is carbon used for finding the number of years any organism lived?
This isn't really relevant, but I'll mention it because it is kind of related. The standard for the mole is carbon-12 isotope. But there's more than one isotope of carbon. Carbon-12 is the stable isotope. Its cousin is carbon-14. And carbon-14 decays. Okay? It undergoes radioactive decay. So what scientists can do is they can measure in a fossil or in a rock that's a certain age, or they don't know the age, and if there's some carbon there, so they can't use just ordinary rocks, but fossilized rock that was originally made, so like coal and oil and all of that stuff that has got carbon in it. They do tests on it and say, what's the rate of decay? And by looking at the rate of decay on a curve, they can predict, when did it start? When was it first living? And they can then work out the age of the fossil just from recognizing the amount. There's a little bit of guesswork involved, but they've got the model for working out aging fairly accurate. There have been some mistakes and there have been some published errors, but for the moment we'll look at we won't worry about those. That's what they do. It's called carbon dating. It's not part of the curriculum, but it's a very interesting science. Okay, next.
Another one from Marcus. How many moles of water molecules are there in 63 grams of water?
Okay, so now we're given a mass of 63 grams of water, of H2O. Now, if we want to know the number of moles, Marcus, it's not difficult. The number of moles is equal to the mass divided by the molar mass. Now, the molar mass of water is simple. You just look it up on the periodic table if you've got one. If you don't, you have to remember it. Hydrogen is 1, and there are 2 of them. Plus oxygen is 16. There's only 1 of those. So that gives us a molar mass of water as being 18 grams per mole. If I know that there are 18 grams per mole, I'm going to say 63 divided by 18, and you can just simply use your calculator to get that, but I think I've got time just to plug that in. 63 divided by 18 equals, and 3,5 moles. Okay? Very important to say 3,5 moles of water. Now, Marcus, here's my question for you. If I know that there are 3,5 moles of water, how many moles of hydrogen are there? With that, from me, we'll see you later.
Thank you so much, John. Well, guys, I need to announce last week's winner of the Casio calculator, and he goes by the name of Katleo Modubi. Congratulations to you, Katleo Modubi. Your name is on Facebook, and we'll contact you. You've got yourself this awesome Casio calculator. So, mindsetters, check out. Your name could be called on the show next week. We love you, and that's it for today. Peace.